All right, today we're going to learn how to name acids. If a compound begins with hydrogen, we're going to name it as an acid. Now, just because it begins with a hydrogen doesn't mean it is always an acid, but for this unit, that's the rule that we're going to use. Here are the steps. Number 1, if the anion, remember that's the negative anion, ends with the suffix "ide," add hydro to the front and change the "ide" to a hydroic acid. All right, so the name will be written as hydroic acid. Second, if the negative anion ends in "ate," we change the "ate" to "ic. So the name will be written as ic acid. Now number 3. If the anion ends with "ite," we'll change the "ite" to "us." The name will be written as us acid. All right, so here's a table that shows you the anion ends in "ide." We'll make that acid into a hydroic acid. If the anion ends in "ate," it'll be an ic acid. If the anion ends in "ite," it'll be an us acid. Now be careful. If you look at the very bottom here are some exceptions. We wouldn't say hydrosulfic acid, it would be hydrosulfuric acid. And then we wouldn't say hydrophosphic acid, it would be hydrophosphoric acid. All right, so let's practice. So what I'm going to notice about all 6 of these examples is that they all begin with H. Okay, so I know that I'm about to name some acids. Now let's focus our attention on the anion that comes second. All right, so notice here I have what we call a monatomic ion, right? So I know that my cation is H1+, but my monatomic anion is iodide, all right? And remember that if we have iodide, that ends in IDE. And I know that IDE will form a hydroic acid. Okay? If I have SO3, SO3, also known as sulfite, ends in ITE. So I know that ite, my anion, is a sulfite. That ite is going to change into an us acid. H2S. Our anion here is S2-, also known as sulfide. I know that the ide is going to change into a hydroic acid because this is a monatomic anion. C2H3O2 is a polyatomic anion, also known as acetate. So I know that this 8 is going to change into an ic acid. Cl, my anion here, is a chloride. It is a monatomic anion. I know that the chloride is going to change into a hydrochloric acid. CO3, that's a polyatomic anion, also known as carbonate. The 8 is going to change into an carbonic acid. Writing formulas for acids. Here are the steps. First, write the cation with its charge. Remember, the cations for acids will always be the hydrogen ion, that hydrogen with a 1+ charge. Second, write the anion with its charge. Remember, the anions are all negatively charged. To determine the anion, remember the following. The hydroic acid came from the anion ending in I. The ic acid came from the anion ending in 8. The us acid came from the anion that ends in ite. Last step, we're going to cross those charges to become subscripts on the opposite ion. So we know hydroic acid becomes ide, ic acid goes to 8, us acid goes to ite. So here are some important exceptions. Cyanide, note that cyanide is not a monatomic anion, it's a polyatomic anion, but it would change it to a hydroic acid. Same thing with peroxide and hydroxide. So there's your cyanide, there's your peroxide, and there's your hydroxide exceptions. Let's take a look at these examples, and we're going to write out the formula for the acids. And we're going to do it step by step by first identifying the cation. And because I know that this says acid, I know that that cation is always going to be my H1+. Now, because I see a hint, my hint is hydro. If I have a hydro and it ends in an ic acid, I know that this anion must be monatomic. And the element that would create the fluor in hydrofluoric acid would be F1-. Now, because the positive one cancels out with the negative one, I'm left with the formula HF for hydrofluoric acid. Chlorous acid, okay? Because I know this is an acid, my cation is H1+. The us becomes an ite. So I'm looking for chlorite. And the chemical formula for chlorite is ClO2 1-. Note that the positive one on the cation cancels out with the negative one in the anion. I'm left with HClO2. Permanganate acid, the ic becomes an 8. So I'm looking for permanganate. I know that my cation is going to be H1+ because this is an acid. I know the chemical formula for my anion is going to be MnO4 1-, that's permanganate. The positive one and the negative one cancel out, and I'm left with HMnO4. Dichromic acid. I know this is an acid, my cation is H1+. This ic acid is going to change to an 8. So I'm looking for dichromate. The chemical formula for dichromate is Cr2O7 2-. And what I'm going to do is I'm going to cross those charges. Right? I notice that I only need one of these dichromates, and I'm going to double up on the hydrogens to create H2Cr2O7. I needed to double up on the hydrogens to cancel out that -2 on the dichromate. Sulfuric acid. I have an ic acid that ick becomes an 8, I'm looking for sulfate. I know that my cation ion is H1 plus because this is an acid. Sulfate is SO4 2 minus. I'm going to cross those charges. I'm going to double up those hydrogens to cancel out with the 2 minus on the sulfate. Last one, I have phosphorus acid, and that us acid is going to change into phosphite. Us becomes an ite. I'm looking for phosphite. Because this is a acid, I know my cation is H1 plus. The chemical formula for phosphite is PO3 3 minus. Note here that I just need to cross those charges. I'm going to triple the hydrogens to cancel out that -3 on the phosphite. Naming binary covalent compounds. Now remember that binary means 2 and covalent means that I'm going to be working with a nonmetal and a nonmetal. Right? Here are the steps for naming. We're going to use the appropriate prefix to indicate the number of atoms of each element present. Note the exception. Mono is never used in front of the first element. So if I have one atom, the prefix would be mono. If I had 2 atoms, di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. We must change the ending of the last element to "ide." Now look at this exception at the bottom. We're going to drop the A or the O in the prefix if the element is oxygen or oxide. Here are some examples. The first formula, SF6. I know that it is safe to assume that there is only one S present and 6 fluorines present. So I remember that the exception said that I'm not going to use mono in front of the first name. So instead of saying monosulfur, I'm going to just say sulfur. Now for the last name, or for the second part of that name, I'm going to include the hexa in front of fluorine and change the ending to ide, I-D-E. pH3. It's safe to assume that there is one phosphorus there, and I'm not going to write monophosphorus because I'm going to, that is the exception. Mono does not go in front of the first name. And I notice that I have 3 hydrogens, but I'm not going to say trihydrogen. I'm going to change that ending to ide to create phosphorus trihydride. CO. I have 1 carbon and 1 oxygen. So I'm going to say I have 1 carbon and 1 oxygen. So I'm going to say carbon monoxide. So remember, mono does not go in front of the first name. P4O10. The prefix for 4 is tetra. The prefix for 10 is deca. And notice here, because this is an O, I dropped the A on deca. This is tetraphosphorus decoxide. As2O3. I have 2 arsenic atoms for every 3 oxygen atoms. I have diarsenic trioxide. And my last one, Cl. This here is Cl3. CaO4. That's trichlorine tetroxide. Notice the A is dropped for the oxide. And the last one, I have 2 chlorines for every 7 oxygen, dichlorine heptoxide. That A is dropped as well. Steps for writing formulas for covalent compounds. We are first going to use the prefix to determine the number of atoms of each element present. Then we're going to write the formula. Dicarbon trichloride. That tells me that I have 2 carbons for every 3 chlorides or chlorines, C2Cl3. Diphosphorus pentoxide. I have 2 phosphorus atoms for every 5 oxides or 5 oxygen atoms, P2O5. Trinitrogen dioxide. I have 3 nitrogen atoms for every 2 oxygen atoms or 2 oxides. Diphosphorus heptoxide. 2 phosphorus atoms for every 7 oxygen atoms. Nitrogen trioxide, 1 nitrogen atom for every 3 oxygens.